Okay, I think we are going to start soon. So yeah, let's make everything turn on and let's start it. Okay. Okay. So welcome everyone. It's great to be here in actually in place for a physical meeting, for a physical work lecture. It's been 2 years of crazy times, and yeah, I'm really happy that I can finally deliver it as it was before in a physical way. Today, we are going to talk about software engineering and basically what it's about and what are the trade-offs that we as architects, as designers, sometimes developers, basically face every day. Actually provided this talk online and was created as being meant as an online talk for Zoom for the last 2 years. So we'll have some challenges also regarding the delivery, but this is a surprise. You will see it a bit later. So let's start. Let's start with the art of the software design. Basically, designing a software is hard because basically, if you are a designer, architect, you should comply and address the requirements of your customers, right? But it depends whom are you going to talk in the company. You will get different requirements and different idea how the product should look like, right? If you're talking to managers, they have their own requirements and constraints. If you're talking to developers, they have a different point of view on this one, right? Development team, test team, business analysis have different requirements for the same product and sometimes even conflicting ones. So you cannot easily deliver something that actually looks like a product, right? But basically, as an architect, your role is to gather feedback from all of the parties and try to look at this from the top level view and find some solutions and resolve all of the conflicts. Also, looking from the big picture helps you to actually identify stuff that those customers, stakeholders do not see because they are living in their own small, sometimes small field of experience or basically influence on the project, right? So they can see all of those simple blocks, but they don't see the whole picture that this stands on something really terrible and that should be either replaced or made stronger or fixed, right? So as an architect, you have to be able to see all the picture to be able to identify potential problems that others do not see. And even if you see a problem and have some idea how to fix it, it turns out that sometimes you have 2 or 3 different ways to do it. But all of them are easy to implement, but you spend much more time to actually decide which one to choose. Because there is no good solution, no golden bullet in many cases. And actually today we are going to talk about such cases where it's really hard to choose a correct solution. Because if there is only one great solution, just go and do it. Of course, there may be some other constraints, some other trade-offs, like for example, time resources, people resources, right? Something is not enough, something is lacking, then you have to make some trade-offs, right? We have to deliver in a month, we have to cut some stuff, right? But today we are just talking about the technology, not about other resources that we may have to actually include in our analysis. So let's talk about the design only. So during the rest of the talk, I will put you in the product architect shoes. You are going to make votes. You are going to actually provide your feedback and make decisions as an architect. So I hope that everyone took their black voting pen from the keynote for the voting. Do you have it? I think you are not having. So unfortunately, we will use an alternative then. Alternative. This one. So I hope this one will work a bit better than during the keynote. At least fair. Of course, I loved keynote, sorry, but please scan your the code and join. I see the counter growing. We have 2 persons joined right now, but I hope to have much more. If you cannot scan, there is a link, ahaslides.com/tradeoff, like this talk. And during the talk, I will ask you questions, maybe not right now, but during the talk, and you will be able to vote on this subject, specific subject. Oh, I hope that's nothing wrong. Yeah, counter is growing. We have 40 persons already joined. Is it decreasing? Go up. Okay, so yeah, please join. If you will not be able to join, or someone will join the room. In the meantime, I will show this maybe one more time before the question actually will be asked. But let's go to the first concern. We are going to talk about strings. As you may be aware of, we have different implementations of strings in the standard libraries. The implementation in GCC looks as follows. Basically, all the strings look the same. They have pointer size and capacity. But you're probably aware of that there is some optimization being applied to a string design called small string optimization. Right? Small string optimization is a buffer that is used instead of the allocation for small content. GCC chose such a design. Basically, their for 64-bit architecture, their string is the 32 bytes of data. They have pointer, size, capacity, and some padding because their buffer is 16 characters long with 0 at the end. So you have 15 characters for data. So actually, you are having some unnecessary padding for case where there is no string, basically where you have dynamic allocation. This actually has some benefits because it means that only capacity is affected by the buffer. So if wherever you want to get pointer, size, begin, and indexing operator, so basically work on data, you don't have any branches. This is member that you get right away without any checking in which mode the string is right now. Only in case you want to check capacity, so maybe do some pushback or whatever, to check the capacity, then the branch has to be taken to find out, how do I find the capacity? Is it the value stored here or just 15 fixed size of the array? Right? But there are alternatives. For example, LLVM. LLVM is 24 bytes, so smaller, better for example, for cache, right? For instruction cache friendliness. Again, capacity, size, pointer. And they chose to actually to have the buffer for nearly entire structure. The first byte is just to select the mode. If I'm in this mode or here, 0 means that we are in SSO. And there is a 0 at the end. So in 24 bytes of type, they chose to have 22 characters of data for a small string buffer. This is efficient from the size point of view, but on the other hand, every member function that works on members have to check in which mode we are, because we don't know how to get capacity, how to get size, how to get pointer, unless we know which mode we are in. So you have branches everywhere, which affects probably a bit runtime. Of course, we have great branch predictors, but still probably we can expect that there will be something slower. And probably you're aware of about third implementation. It's really similar. It's Folly from Facebook. They are actually smart enough to make 23 characters here. And it's possible to just have entire structure as a buffer in this case. The trick is done here, basically with this last byte that basically serves as a size or 0. The trick is done in that fact that actually this is not a size, but inverted size. So it's capacity minus size. So if you are out of data, out of buffer, your maximum size, this is 0 because there is no more capacity. So it's inverse capacity, let's say. So this may look even better than LLVM, right? And it's really hard to find out which of those are better, because both of those are great companies, all of those designs have sense, and it seems there is no golden bullet to find it. Also, I find a few quotes that are interesting that I would like to share with you about the design. Especially there are quotes from LLVM authors, the Howard Hinand. This is a long time ISO committee member and also the author of StudChrono, one of the best libraries I know. And he said that the major design of LLVM's approach was to minimize size of, while making the internal buffer as large as possible. Basically, the rationale is to make speed of move construction and move assignment as fast as possible. Because if you have less data, move is faster, because move is just copy of those pointers and sizes, right? So having like GCC having like 8 bytes more, it's longer to do a move. Also, as an answer to Facebook design, which may be seem to be more smart, and because they have additional character there, the answer is, well, that's clever. However, if libc++ adopts this, it would require libc++ to give up one of the characteristics that I like. A default constructed string is all 0 bits, which is really cheap to default construct. Just 0 in the memory, like memset or whatever statically erased memory, is default constructed strings. You don't have to set anything during default construction, like inverse size. And that's also a valid concern here, right? So having those 3 features, please try to find your favorite one. And we are going to find out which would be your choice if you were architect with all this knowledge, to find out which one will work the best for you, right? GC size is the biggest one, LLVM, and Folly is smaller, so move is cheaper. Small buffer size in Folly is the biggest one. Move performance, fast. Branches, only on capacity, here everywhere, in both cases. Default construction, all 0, fast. So what would you choose? Coming back here, if you didn't join, please join. And we are going to make a vote now. You have 30 seconds. Let's see. It's interesting. You still have 15 seconds to vote. Yeah, so it seems that our favorite in this room is LLVM's approach. I like it really much. Also, maybe because I quoted Howard. Everyone knows this is done by Howard, so it has to be great. but yeah, all of them are great designs, and it's really hard, as you can see, to find the golden bullet. So as I said, sometimes you know how to implement stuff, but it may take a long time to decide which one to choose, right? So this was just a warm-up. We are going to talk about such stuff for entire talk. But thank you for voting. Please keep your phones connected, because there will be more votes soon. Another interesting concern: different variants of exception safety. Let's consider such simple code. We have established connections, and int, let's say port is represented by int, so you have some first port and the last port, so some range of ports we want to establish, from 1 to 20, for example, right? And it may throw, so you have exception handling here. Also, you have a structured connection that takes a port, stores the port here, and if something bad happened, we are throwing an exception, right? And returning port as a member here. Nothing fancy here, it's just that the construction may not succeed. We have vector of connections, and you have established connection, the function that takes the first port and the last port, so the range of the ports to set up. We're having retry counter set to 10, and you are checking if connection is empty, so we actually didn't do anything yet, or we failed to set up the first one, or basically the last one in our connections is different from the last, so we didn't finish the process. We are trying to add a new connection. As you've seen, it basically may fail during construction, right? And we have some retry number, so we can retrying stuff in a while loop, right? Alternatively, when the counter is down, we are saying that we failed, and we are throwing the exception out of this, even for further processing by outer means. Simple enough, right? And add connection is as simple as this one. connection and place back. Right? It is as simple because actually it provides exception safety guarantees. What is the exception safety guarantee of this call? We have 4 of them, right? We are going to talk about them soon. This is strong exception safety, right? The question is, even though probably most of you realize that we have 4 exception safety guarantees, because when I asked it during interview, people know about it. When I asked during workshops, people know about them. But what was the last time when you actually thought about exception safety writing your own code? What was the last time you reviewed the exception safety of your algorithm? How often do you analyze exception safety of your custom class assignment operator, which is really easy to be broken and in case of exactly exception safety? Which exception safety the latest library utility you written provides? Did you ever ask those questions to you writing some code? Right? Even though we know about them, that there are 4 of them, right? Basically no throw, so no except function that never throws. No exception guarantee means basically anything can happen, like exceptions may be thrown, and then you have memory leaks, crashes, resource leaks, and so on. And between them you have also basic and strong, right? Basically strong means that if exception happens, the state of the program is like this function was never called. If the function did something out to this point, it has to undo stuff. It's like a transaction. Either everything is done or nothing is done. So if there are some side effects, those has to be restored. The state of the program should not change. With basic exception safety guarantee, you have to basically program is in the valid state, but maybe you have to do some cleanup manually, right? And this what you have to do actually is documented by specific product you are using. What is the state after the exception? My basically experience from doing workshops for quite a long while already is that even if theoretically we know what are exception safety guarantees, we often ignore them in our production code. Just don't think about this writing our code, and I would like to raise your awareness here to this subject, because this is one really important one, right? We actually expect standard library to be strong exception safe. If it was not, everyone will complain that it is something that we cannot use. Imagine that standard library provides only basic one. So our add connection instead of just place back forces us to do something like this. If connections are not empty, look for the last iterator, do the previous one, because this is the last one that we actually expected to push, right? And check if it's dirty. It's not set up correctly, right? If it's dirty, if it was not able to be set up correctly, it's some garbage there, you have to erase it, and then try to place back again. Would you like to write code like this one? For every pushback? These are the benefits of being strong exception safe. But when you will go home to your projects, please see your assignment operators, for example, if they are strong exception safe. If you provide similar user friendliness to your users, then the standard library does. Because we don't want to write code like this one. Right? This is something for you to take as a homework, also for me, right? Because we don't use them, analyze them that often as we should. And there is one big exception in the standard library from that I know at least. This is called variant. Variant is another engineering trade-off, and we are going to basically discuss this right now. Variant in standard has values by exception state. It's a special state that basically can be reached only via exception, because by default variant cannot be empty. There's no such thing like an empty variant. But variant also in standard cannot allocate memory, so everything is stored in place in the buffer of the variant, right? So consider you have variant of type A and B. Instead of in case of switching from A to B, first you have to destroy A, right? We are destroying A, trying to create B, and what happens if B fails to create? How to restore the previous state and provides strong exception safety guarantees if A is already distracted, right? So in this case, it's not possible. In such case, we are ending up in valueless by exception state. How you can handle this? For example, let's assume that you have two sockets, one basic, like OS one, that's always there, and maybe one fast, that basically requires you to have kernel bypass drivers installed, right? And you have variant of those two. You have some process function that basically at the very beginning tries to switch a socket to a fast one. It may fail. So in the exception, you have to check if it's valueless by exception. Actually, if it is, because there was an exception, you have to reset socket to a basic one, because something failed to set up a fast socket for your processing. This is the penalty of providing basic exception safety guarantee only, not a strong one. So you may say Stud.Variant is broken, right? And there are also alternatives that provide strong exception safety guarantee. Boost.Variant provides never empty guarantee. How come? How is it possible? This is how it's stated in documentation. In case of a potentially throwing copy constructor, copy construct the content of the left-hand side to the backup heap that I just created. So variant does the dynamic memory allocation, does a buffer, and copy construct actual content there. So you have memory allocation cost and copy construction cost, right? Consider this an array of 1,000 elements. Then we are destroying something that's in the variant, copy constructing content of the right-hand side to our variant, and basically if there is an exception, we copy the backup back again, hoping that it will actually succeed, because maybe it doesn't have to. In the event of success, deallocate the data pointer by backup, right? So we are freeing the memory. So this is the cost of providing strong exception safety guarantee to variant, right? It's easier to use. You don't have to care about its state, but it requires dynamic allocation. It requires some copying. It's slower. On some platforms, it may not be no-go, like embedded platforms. They cannot afford dynamic allocation. So you'll not be able to use variant there. Moreover, Boost.Variant does not provide allocator support. So you cannot say how you want to allocate this memory. And now again, we have to choose Stud.Variant, basic exception safety only. You have to make cleanup and check for the state after the switch or assigning new data, but never allocates memory. Fast can be used in embedded and constrained environments. Boost.Variant, easy to use, slower, and maybe sometimes no-go in some solutions. Let's see, what's your opinion in the room? Did it broke? I don't see anything happening. Strange. I see like 6 persons only reconnecting. What happened? Oh, okay. We have. This was a surprise, so we cannot cheat. Nice feature. Oh, actually, it disconnected for a moment. And probably I should have some wire, maybe, or maybe there are too many persons with Wi-Fi in this room actively using it. I don't know, but it seems that we did a good choice in the standard community, right? ISO committee. It seems that we have the design that's actually preferred by most of the room, which is encouraging. As the ISO committee member, thank you for basically acknowledging our work. We are doing our best. But yes, as you can see, it's never easy. Of course, there are easy answers, but sometimes it's really hard to provide something that basically will satisfy everyone. Okay, let's try the next one. Next one actually will be from my point of view, because I would like to use you as guinea pigs and provide me feedback from my library. Probably you've heard me or see some talks of me on about the MP units library. It's a physical units library that I write. It was intended to be included in C++23, but because of those crazy times, at least we have to wait to 26, I hope. But if it will not be in the standard, still, I think it's a fine library, so I encourage you to test it and use it. But still, I have two problems that we'd like to poll you today, because again, it's hard to find out what's the best solution. But first, let's do some introduction for those that are not in the subject. Basically, what's a quantity? Quantity is a property of phenomenon, body, and substance where the property has a magnitude that can be expressed by means of a number and some reference. Reference can be a measurement unit, right? So for example, 103 kilometers of length. This is a quantity, right? 70 kilometers per hour of speed, right? Those are quantities. So number and unit, and sometimes also connected some dimension, because sometimes unit can be used in different dimensions, different things. So quantity class template in my library right now looks as follows. We have dimension, unit of this dimension, and representation, by default double. So if you want to instantiate it, you have to provide units and no like using namespaces declarations. You have to specify units quantity of Unix ASQ SI dim length, because you want to have quantity of length. And Unix ASQ is SI kilometer with the default double. If you want to provide your custom representation, it's even longer. As you can see, it's quite verbose, and that bothers me, right? It's easy to understand, but if you're not using that namespace Unix ASQ SI, it's actually quite long to type. So we are looking for some alternatives, for something that will make this easier and faster to work with. So solution number one, dimension-specific aliases. We have alias for length, that basically is a quantity of dim length, speed, quantity of dim speed, which saves us a bit of typing. So it looks like this. Units ASQ SI length, kilometer, speed in kilometer per hour. It's already better, shorter. Benefits. Cheap to standardize because it has to be provided only per dimensions, not per units. There are like limited number of dimensions in SI, for example, like 150 or whatever, right? Fast to compile, because those are alias templates. Alias templates are the fastest to compile. Works both for literals and regular variables. By this I mean that I can provide a compile time known value here as well as like function argument, runtime argument. It works. Cons, still quite verbose, right? It's still quite long. And namespace has to be repeated for a unit. So you have namespace for alias and namespace for unit, the same prefix, which is probably suboptimal. Class template argument deduction for alias templates does not work here because there are some additional parameters. So we cannot deduce, for example, representation type from the initializer. So maybe solution number two. They are called unit-specific aliases. So we provide the alias for each unit, not only for each dimension. So we say that using km is length of kilometer in representation. The representation is provided here as parameter, by default double. And the same for kilometer per hour. With this, we can type something like that. I did here using direction, the directive here, and I have SI length kilometer, default double, SI speed kilometer per hour of integer. With C++20 class template argument deduction, this actually works. This one will deduce double from the initializer, this one will deduce integer. And it's possible to be more terse if desired, because sometimes like km or km per age, it's not. It's better to describe here. So you may provide prefix, what you are dealing with, or just be like UDS, short one, in this case, which can be a benefit. If everyone knows exactly what S, M, or other letter you are using means in the specific domain, or function, because you can do this per function, not per entire project, right? Pros, fast to compile because still these are aliases, works both for literals and regular variables, the same as previously, user can choose to either use a long or terse version of it. Cons, quite expensive to standardize, right? Because it has provided for every unit of every dimension. So this counts in thousands, probably, right now. So let's see into the third solution that we have. By the way, all of them are working correctly in my library right now in parallel. And I promise you, with whatever you choose, I will show you tomorrow during my talk. This will be default one that I choose during the presentation tomorrow. So please choose wisely, and I have to work to do today evening to switch my talk to the one that you choose today. So we'll see if actually you made a good choice, how it looks like in real life. Quantity references, they're provided only for name units only. So we have reference, this is a new type that basically encapsulates length and unit, and we state this is kilometer. Time and hour, hour. These are variables, not aliases, right? Like objects. And if you want to provide some speed or length, you type it in the well-known form, maybe from Boost units, if you are familiar with this one, right? You are using multiply number by a unit, and you end up with SI length of kilometer and double. If you want to have speed, you have to type it this way. If you forget about braces, actually in our project it will not compile, because we basically assume that we want to be safe. So you cannot divide a quantity because it will decide that it's 70 kilometers, and you want to divide 70 kilometers by reference, which is not allowed, right? So you have to create a reference from those and then multiply by number. This is for safety, but you have to put those braces sometimes, those parentheses. It is also possible to define your custom quantity references easily. You just specify kilometer per hour, it's that, and then use it. And this is all you have to do to specify new derived unit. Pros, medium effort to standardize because it's provided for named unit only. There is less name units than all of the units in NSI. There are only like meters, seconds, and some maybe prefix versions of those, but only probably mostly for the base quantities and some derived ones like joule, watt, but others are just derived from those. Works both for literals and regular variables. Again, easy to compose custom references for unnamed direct units, as I shown you on the previous screen. Cons, slower to compile, because those are actually class template instantiations rather than just alias. Sometimes awkward to type, 20 meters per second divided by 10 meters per second square, a lot of parentheses. There are a lot of objects with short names that often shadow users' local variables, because those are objects, not types. Do you have already an object or argument of the function called m, t, n? Probably you have, right? So you have collisions if you include those in the same namespace. Sometimes hard to understand. If you have also one letter arguments like distance and time, then what does d times m means? What is the argument? What is the unit here? Is it a ton or time, right? Solution number 4, user-defined literals. So something that we know already from Chrono, right? And it's even harder to standardize because it provides 2 versions for integrals and floating points for each unit in the system. So if there was 1,000, right now is twice as much. But the use case is quite fine. In our case, we have to use this Q prefix. Actually, we're using underscore Q prefix. This is what you will have in the standard if you are allowed to get rid of this underscore before Q. But we had to use Q because otherwise we will have some collisions with what's already there. So some of the units already collide with literals for some math descriptions that are used, for example, by GCC. So you have to use this Q prefix. Compatible is to Chrono, terse and easy to understand. But there's a long list of problems. This is the slowest to compile, the most expensive to standardize, 2 instances per every unit. It works only for literals, not for common variables, right? You cannot put function argument before literal. So it's only for compile time non-constants. So mostly either physical constants or unit tests. This is where you're using constants in your code. In other cases, you are dealing with arguments, so this tends to be useless. And you are left with this long thing that we started with. No control over the representation type. It's either int64 or long double. You cannot have short. Car, if you are dealing with small values, right? On an embedded platform, is the longest possible because this is how UDLs work. Either this one or this one. And also cannot be disambiguated with the namespace. For example, we have centimeter both in the SI system and CGS system. If you include both, you will have a collision. Which centimeter you wanted to use? Because UDLs cannot be prefixed with the namespace name. So, also, of course, we could provide all of them, like we have in our library right now, right? But basic standardization takes time. And probably it will be not accepted in this case. They will ask me to make a choice. So I'm asking you to make a choice for me. Sorry, because it's hard. Time is needed to discuss this in working groups in ISO committee. Prepare the ISO specification, implement in various implementations, GCC, Clang, everyone has to implement this, right? And then we have to teach it and learn for every one of you. Right? This is a long process. The more complicated it is, the longer it takes. So, just to compare on one slide. Dimension aliases, unit aliases in terse version, sorry, in the longer version, in the terse version, so that those has two different options, quantity references, and UDLs. So you can find your favorite. Also, I have a long table of all of the features that we discussed. The bold one with blue is basically the better one. So literals and variables support. And previous user provided representation type, explicit control over representation type, readability, possibility to resolve ambiguity, hard to resolve shadowing issues, controlled verbosity, easy composition of derived units, implementation and standardization effort, and compile time performance. So I hope that you are ready to make a choice. And let's come back to our voting platform. And let's try to find out what's your favorite. It seems they have a lot of work to do today in Vinik, because previous groups always wanted to have quantity references. Okay, so tomorrow we see each other with unique specific aliases in our presentation. See you there. All right, and the last thing that I wanted to discuss with you, the Downcasting Facility. Maybe you've seen my talks about this one. This is a really great thing that I'm really proud of, but also it turned out that it may expose some problems. What this is about? Basically, it allows us to have really nice user experience. If you're typing something like this, average speed, you're dividing length and time, returning speed, actually the type that you are getting here is a really nice one. If you provide average speed 140 kilometers to hours, you will get 70 kilometers per hour. This is something that's printed because it knows that actually the type here of S is dimension of speed, kilometer per hour, because of the downcasting facility. And it's the unique feature for all of the libraries that are there, because based on the ingredients, like dividing length by time, it doesn't provide me a type called like exponent of length divided to the first exponent of length divided by exponent of time. It does it under the hood, but basically it knows that user provided a nicely named name for it. dimension speed. It also knows that if I divide kilometer per hour, so I end up with some crazy ratio, with some 3600 divided by something, or no, kilometers by seconds, right? 300 seconds. That actually it's also not a ratio of some strange ratio, but it's named by the user, kilometer per hour. I want to see this type in the error log, in the debugger, right? Rather than end up with something made up by the library from the ingredients, because this is what other libraries do. In order to do so, I have to inject 2 additional classes. It's CRTP design pattern, so the type defined here goes here as the first argument. The type defined here goes here as the first argument, so curiously recurring template parameter idiom. I will not go through the design right now. I discussed the design on other talks. But a problem is that this may break one definition rule. One definition rule basically tells that for translation unit, only one definition can appear in entire translation unit, right? It's simple. For program, basically it's similar, but different. For program, it means that if you have non-inline function variable, basically there should be only one definition. If it is inline function variable, it has to actually be visible in every translation unit because it has to be inline, so you have to see the definition, right? And for classes, it requires that it appears only in one translation unit, where basically you'll be using this one. But this is C++. C++ always has some buts. Doesn't bother you. There can be more than one definition in the program, as long as each definition appears in a different translation unit, because in the same you cannot provide more than one. Each definition consists of the same sequence of tokens, so it's lexically the same. It's even not semantically the same, but lexically the same. And some other things. Otherwise, the behavior is undefined. So how it basically affects us here? Let's assume that we have this our function, average speed, that divides stuff, prints it, and returns s. Right? And we have this function average speed here included with the include, and you also include the definition of speed. So we know exactly what speed, what kilometer per hour. And that's why we see this nice basically output here, and also we see this nice type in the debugger error log. But another translation unit in our program calls exactly the same function with the same arguments and does not include speed. With this, our downcasting facility cannot see the definition provided by the user. The type, like dimension speed or kilometer per hour, is never provided to the compiler, so it cannot generate it from facility. So it means that we just broke one definition rule, because the same function, the same definition, provides 2 different outputs. It's defined differently, even returns different type to the user. So it looks bad, right? But on the other hand, this is how some customization points behave already. Let's consider structure A, structure B. It has value and a pointer to A. And we have some streaming operator to print it. File 1. We defined a swap, what it means to swap Bs. We decide that in case of Bs, we just want to swap the values, not the pointers. Maybe it's some cache, whatever, we don't care. It's broken, but it's basically, this is what our implementation. We have initialization here, 1, 2, 1, 2, A1, A1, so we have 1, 1, 2, 2, right? And we are doing range swap. After range swap, we just swap the values from the first element, and second is like it was during initialization. So swap works, right? And now you have second basically unit that does exactly the same, but doesn't provide swap customization point, and provides different output. The same problem with stud swap. The same problem with stud begin. For example, if you have custom overload of begin and default implementation provided by stud. Stud size, stud data, a lot of those. All customization points with default implementation will have similar behavior. And we have those already in standard. However, not all of the customization points are bad like this, because, for example, if you are not defining streaming operator for your types, they try to print it here will fail, right? Because there is no default implementation how to stream a type. So most customization points, or many of them, will just not compile if you don't provide definition. So in our code, if you don't provide speed, we may choose to not compile. Do not provide a default implementation. That's a valid choice. So, solutions. Keep it as it is. We can say that the downcasting facility is great. It basically helps a lot in the user experience during error log analysis, debugging, and actually the whole purpose of this library is to generate errors during compilation. There's no needs for other needs than this one. Find your errors. So we want to be able to analyze those errors nicely. But we'll have to document the fact that basically the same physical system definition will have to be provided in all translation units. Because otherwise, if you have 2 headers in one translation unit, in another one 3 headers, you may have different results and break one definition rule. So you have to have the same set of systems provided in every unit. So maybe some header setting my systems and include the same header in every translation unit, right? Modules should help. We can create a module that is called SI, and it will immediately include all of the SI at once. It is pre-compiled by the compiler, because right now it takes a lot of time. Sorry. But this library was basically designed with modules in mind. So it will pre-compile once and just reuse later on. But still, we may have some problems if we will mix SI and CGS, for example. In one translation unit, we'll just import SI, into a second we'll import SI and CGS, and we may have some strange behaviors. Second solution, compile time error, when the resulting dimension is something that is undefined by the user. Right? So we end up with something like this in the error log and in the debugger. Unknown dimension of exponent length 1, exponent time -1. This is something similar to speed, right? But it's not provided as speed because compiler doesn't know about this type. So we assume that everything has to be predefined. However, it means that some temporary calculations in our code will not compile. In many cases, when we are splitting some long mathematical operation to subparts, we don't care what's the quantity here. We care the speed, but here this is just something temporary. We are not going to print it. We are not going to provide it to the user. That's just temporary calculation. And then after square rooting this one, we know that speed again. Right? And if that doesn't seem bad, this is even worse, right? Because this is the same equation. The same result has to be provided here, and it will not be allowed. Because it will result in a type that is not known. So we will be forced to provide some strange, unrealistic quantities just to make some temporaries work correctly. So I think that may constrain the library too much. And solution number 3, get rid of this facility. This is also a valid choice. The user should be responsible for providing a specific type. So we may decide that this operation returns us this one, unknown dimension, exponent length, exponent time, and this is the result. And then you can implicitly basically convert this to something provided by the user explicitly. And then it will print correctly. It will be provided by the compiler error correctly, because this is strong type provided by the user explicitly casted here. And in order for the user to do so, the user has to provide this header, right? It also simplifies the standardization effort, because convincing the committee that it's good may be challenging, even though as user we claim that's great. However, this function will not be that easy to solve. We cannot address this function that we are analyzing all the time, because if we divide length by time, we end up with this unknown dimension, and we cannot print it as speed. We'll print it as unknown dimension. So we end up with something that basically will be some ratio of some value, not kilometers per hour. It will be printed in meters per second. It will be printed in the base units of the dimensions that are provided, rather than in kilometers per hour. And it's not only about printing, right? Just to make it straight, it's about compilation errors, it's about debugging experience. So, again, we have 3 choices to make. Let's see what's your preference here. Oh, you want me to suffer in the committee, I see. Oh, it's interesting. Wow, I was afraid. So hopefully, I don't have anything to do because I leave the status quo right now. But it was dangerously close to make the compile time errors. Yeah, this is a valid solution. A lot of customization points decided to do so, right? But all others basically will behave the same. So be aware of this. This is one definition rule violation. If you have customization points, and for your own types, they should be visible everywhere when you're dealing with those types. So the best would be to basically define them in the same header than the type. If you cannot, because this is some, I don't know, Qt type, and you are doing this in your own library, you cannot put this in the same header. Then be really careful that every time you deal with this Qt type, you're also including your customization point header, right? Because otherwise you will have exactly the same problems for customization points that provide the default behavior. Because this is nothing different, this is just a customization point. Okay, so to summarize, first of all, thank you for the feedback. I really appreciate that. I will provide the slides tomorrow as expected, as required by the audience here. And yeah, let's summarize this stuff. Designing is hard. Different customers have different various expectations, experience, constraints. And by this I also basically mean you guys here. Actually, I did this talk 3 times already for different audiences, and I always get different results. Depending on the audience, on I don't know, time of day. We are maybe the fact that we just ate lunch affected us, right? Often there is no golden bullet solution. As you saw, all of those solutions were valid that we discussed today, and you have to make some choices anyway. And there is sometimes no possibility to make all of them like parallel solutions. We cannot have 2 strings in standard library, right? A bit bigger, a bit smaller. C++ standardization takes time. We have finite resources, right? And actually, COVID made it much worse. I hope that C++23 will be much bigger. That it will be actually because of COVID times. Also, in order to improve the quality of the language in the future, as things will be later on maybe standardized, please, if you are dealing with physical units library or linear algebra or any other subject that is meant to be standardized soon, please provide your feedback. Please try our libraries, right? We need your feedback. We need to make sure that it works for your domain, that you have all of the requirements are fulfilled. We need to have your information. Which solution would you prefer? Because later on, we will just go to the committee, we'll say, this is what we have for 5 years. No one said it's bad, so let's standardize this one because it seems a stable and good solution. And if you will not be interested in this before, later, you will maybe suffer or will have some problems stating that basically we provided something that's stupid, that doesn't work and it's broken, right? We do it in our best effort, mostly in our free time. We feel that that's ready, but we need some basically feedback from you, from the production, from the community, that it works for you. Not everyone was writing like libfmt library that has thousands of users. So Victor actually had easy task to do. He had a lot of feedback, right? I actually feel that library like MP units it's harder, especially that it requires C++20. So not everyone can try it right now. Linear algebra guys probably also do not have much feedback. But those will be parts of the standard, probably. Maybe. because we may just end up with in Conan, which is also fine. But if we end up in the standard, we want to make it as good as possible because we are really bad in fixing our mistakes in standard. We cannot break APIs, we cannot break APIs, we cannot provide V2 version easily, right? When we find out after 3 years that something can be improved. I can always release version 2.0 or 3.0 at my library on GitHub. Break stuff and don't care, and make 5 guys that basically can break stuff, make them happy because they have better features. With standard, this is not possible. We have to do it right at the very beginning, from start. That's why we need feedback right away. Naming is hard. That's always the problem with designing, that naming is the hardest part of it. And if you would like to provide some feedback, if you would like to try, please go to mp-units github.io/units. There is a great documentation, at least I think it's great, as for C++ standard projects. And you will find all information there. Also, we have integrated Gitpod lately, which is just great. You can just click, and in a few seconds, you are with fully set up environment to work with. So you can also try this one. Thank you. Do you have any questions? Yes?
I wonder how you weigh feedback from beginners and experts, because I assume that the experts are more likely to give detailed feedback, but what they prefer might not work well for beginners. So how do you reconcile this?
So yeah, so the question is, how do I weigh the feedback from experts and beginners, juniors in programming? Because experts probably can provide better feedback, but actually there is more juniors and more people with let's say average knowledge of C++, not ISO C++ community level experts, right? Those will have probably a lot of opinions and probably great opinions, but those products are for you, not for them, right? I don't want to create a program that can be only handled properly without any issues, without any errors by ISO committee members, right? This is for community. It has to be easy to use. It has to be friendly to use. It has to be hard to abuse, right? And that's why we ask you, we're coming for feedback to everyone. If you are moving to C++20 compiler or just want to play with in Godbolt, because Godbolt also has MP units, try it and provide feedback how it works. I understand that it cannot be maybe used in your project now or even in 5 years from now. It sucks. But this is the reality that C++20 will be for many of you after some time. But even though if you are in the subject, in the domain, please try it and find it out. And maybe use this as an opportunity to say, well, if we move and upgrade our compiler, we could use this great library, right? So yeah, other questions? If not, thank you very much. I will be here. See you tomorrow with the aliases on physical unit stock. Thank you very much.